Hello everyone. Myself Subraj Rajesh Agre, roll number 16, and today's topic for presentation is cell balancing, fault detection, circuit design, and communication in BMS, which is battery management system, which are essential parts of electric vehicle technology. First of all, we will discuss about cell balancing and communication in BMS, which are related topics to each other. Electric vehicle batteries are the heart of EV, and their performance and safety rely heavy on effective management. This Two crucial aspects are cell balancing and communication with the BMS. Within the BMS, communication within the BMS, cell balancing ensures that all the cells in the battery charges and discharges evenly. Where and communication in BMS allows to monitor the battery states in real time, ensuring about its operate safely and effectively, which also monitors about charging and discharging of battery cells. So first of all, we will talk about cell balancing. We know that so we First of all, we will talk about cell balancing. Battery pack consists of many individual cells which naturally differ slightly in voltage and capacity. So if we see that old electric vehicles used one whole battery pack, if it would get damaged or we need to replace the battery, so we need to replace whole battery or we need to change the whole battery, and it will cost around 50% of the vehicle. So it was very costly method. So instead of using whole battery pack, now the new battery technology, where you can see here the number of many individual cells are placed in such a way that it forms one battery. And this cell balancing plays an crucial role here of monitoring and ensuring the safety of these many individual cells of charging. It will get charged equally and discharged equally. So the age of this whole battery pack would extend, and it will also work efficiently for for improving the range of whole electric vehicle. Now this technology also works like if the number of some individual cells are getting damaged, so we can only replace certain damaged cells, not without replacing the whole battery. So it is also cost effective method for battery system or battery technology. In cell balancing passive method, one of the common is passive balancing. Here extra charge from higher voltage cell is dissipated and using heat resistors. It is simple and cost effective, especially for smart EV system. However, the downside it is that waste energy as heat and can be relatively slow, uh, requiring proper thermal management to handle the heat generated. So here we can see some topologies where we can use switched capacitor, its efficiency is moderate, balancing current is low to medium, complexity is medium, and buck boost converter is like AC to DC, which is used with AC to DC converters and DC to DC converters, where it helps in balancing the proper voltage for power electronics part, which also helps in efficiency in battery systems. Uh, Now we will see the communication in BMS. Communication in the battery management system is crucial for monitoring battery health, managing charging, and optimizing the performance. BMS system communicate internally between components and externally with other vehicle system and charging infrastructures. Uh, Here internal communication in electric vehicle is like cell monitoring. Individual cell voltage, temperature, and currents are monitored and transmitted to central controller, which allows the real time assistance of battery health. Uh, in modular distributed BMS, in modular or distributed BMS architecture, cell control communicate with each other to manage data and tasks. Centralized BMS, high level voltage and BMS system have sophisticated internal communication for managing cells, while low levels centralized BMS simply measures voltage. Communication protocols in BMS. The most widely used protocol is CAN, which is CAN Control Area Network, noise tolerant and ideal for real-time data exchange. Simpler protocols like LIN are used where low cost and limited speed are acceptable, while Ethernet is preferred for high-speed data transfer, and emerging with wireless protocol are also gaining popularity as they reduce the weight and complexity of wiring harnesses. The case study of BMS and cell balancing in EVs. Here are the three main models of electric vehicle which uses uh, cell balancing and proper communication in BMS system. So Tesla Model 3, which uses CAN bus to maximize the battery efficiency and lifespan, whereas similarly Chevy Bolt and Nissan Leaf also use similar technology for communication in BMS and cell balancing technology. So future trends in cell balancing and BMS communications are using wireless BMS, which reduce the wire complexity and weight in overall the vehicle. AI predictive balancing is also which also uses AI algorithm forecast for cell balancing to AI predictive balancing, which uses AI algorithm forecast to predict the cell fault and detect it before it occurs. Mm, Solid state batteries, new chemistry challenge traditional balancing techniques requiring innovative management system, which will also help in battery technology, cloud analytics, remote monitoring and data analytics, where we can uh, monitor and analyze the data through cloud system in real time for various vehicles which are running on roads. So now we will talk about fault detection, and next we will talk about circuit design. Let's now talk about fault detection in EV vehicles, which involves the identifying and diagnosing problem in vehicle components, which includes the powertrain, energy storage, and supportive system. Where we can see in first image that this one port is OBD port, which is placed under the dashboard of Copilot, and second one image is of OBD scanner tool, so where we can plug the OBD scanner tool in OBD port and scan or diagnose the vehicle. And the second way is issue diagnostic, but whereas these methods were used in fuel vehicles, issue diagnostic is engine control unit diagnostic, where we know EVs do not have internal combustion engine, so we do not need engine control unit diagnostic, but we need electronic control unit diagnostic. So here also we need OBD scanner tool for scanning or diagnosing the EV circuitries, or where battery system is working fine or not. Issue diagnostic is where we can check electronic controllers are working well or not. So some common faults in EV circuits, we can see battery faults, inverter faults, motor faults, where in battery faults over voltage, under voltage, or thermal runway. While after using vehicle for longer time, we can face a heating issue of battery. So and next inverter fault, short circuit and open circuit of the circuitries, or motor fault where winding part or bearing failure, sensor issue we can face. which are common faults in circuits, and we can scan that all faults or scan that all faults through OBD scanner tool or ECU diagnostic, which is electronic control unit diagnostic. Some fault detection techniques are current signature analysis, voltage monitoring, sensor based monitoring, and model based detection. Whereas sensor based monitoring is also one of the best technique, where we can see and in the dashboard some signs with LED glow are given, which are connected to the sensors in vehicles, so that even if there is some problem, the driver can immediately detect the problem. And if we introduce the AI algorithm in fault detection, the AI driven predictive maintenance can also where maintenance so predictive maintenance cuts downtime by 30%. Now we will talk about circuit design. So key circuits are main circuits are power electronic, inverter, DC to DC converter, and battery management system. For this all system, we need a proper circuit design. System architecture is higher voltage is 400 to 800 volts, and lower voltage it is up to 12 volts. For design, focus will be on power density, efficiency, and thermal management. Like example is Tesla Model 3, which uses CISC MOSFET for 97% of efficiency. Uh, Key components and functions for circuit designing, which we can see here: EV chargers, traction inverters, DC to DC converters, battery management system, and control system, microcontrollers, and PWM. Here, EV chargers that converts AC to DC power, which again DC power is stored in battery, and traction inverters that powers the motors by converting DC to AC, which again from DC from battery to AC to the motor to power the drive the electric motor, where DC to DC converters that manages the voltage levels in EV electric vehicle. BMS is the that oversees the battery health by monitoring battery voltage, current, and temperature, and regulates the charging and discharging process to maintain the safety performance. Control system that regulates various operations using microcontroller and PWM signal. For instance, we can see Tesla Model 3 uses MOSFETs in its inverter and and it achieves 97% of efficiency. So thank you all for your attention. I hope this presentation helped you well to understand the crucial role of cell balancing, fault detection, circuit design, and communication in EV battery management system.